Hey guys, Orthobro here. Today we're going to go over polynomials. Should be quick and easy. Let's go over the vocab real quick. The vocab is pretty easy. It can get a little complicated, to be honest. You might mix some things up, but you'll learn over time. So right here we have three terms in this polynomial. Okay. And then in these terms, there are factors. So let's take 5x squared, for example. 5x squared has a factor of 3, or it has 3 factors. Let's get a better color for this. It has 3 factors because there's 5 times x, because it's squared. Adding on to this, whichever has the highest degree would be the leading term, right? So right here is a leading term, 5x squared. Let's see if we can get a better color. Here's a leading term because it has the highest degree. Right here on the right, the 9. The 9 would actually be considered a constant right here. There's no variable, so anything, it's just a constant. And right here, these are coefficients. So the 9 is a constant, the 9 is a coefficient. That little one right there. As you can see, this is a secondary degree polynomial because there is a 2 as the highest. There are third degrees, but we'll get there when we get there. Alright, so starting off with some practice problems here. We could number them. Why not, right? Here's A, B, and C. So starting off with A, should be pretty simple. You take that 2x and you distribute it right here and right here. So this would give us, because we distributed 2x times x, which would be 2x squared, and then 2x times 3, which would give us 6x. And that'd be our final answer. Now for B, we're still going to distribute. It's just a little more steps. For B, we're just going to distribute again, like we did last time. 2 times 3x, and then 2 times 2. Then we'll distribute again to 3x times 3x and 3x times 2. This would eventually give us 3 or 9x squared. These we're adding, well, 3x's. And then minus 6x plus 6x minus 4. And then these will cancel out. And then we're just left with 9x squared minus 4. And that's our final answer. Now for C, 2x plus 4, we're actually going to expand it. There's a common problem that some students have where they try to take the square and they try to do square of 4, 16, and they try to do square of 2 and x. That's not how it works. You're going to have to expand it. Okay. Into 2x plus 4, and then 2x plus 4. So let's do that here, right? See if I can get a different color. Now this is how you'll expand it, and then you'll just do what we did with B. We would just use the distributive property and go here, then we'll go here, and we're just multiplying. That's all we're doing. It's pretty simple, even though we already did it. So 4 times 2x, that would give us 8x. And then 4 times 4, that'd give us 16. And 2x times 2x would give us 4x squared. And now 2x times 4 would give us 8x. Now with this, we're going to see that 8x plus 8x is 16x, and 4x squared is our leading term, so that will go in front. So let's get that ball rolling. There you go. That would be your final answer. You can simplify it even more here if you really wanted to, depending on what the problem is asking from you. But you see the greatest common factor is 4 between all of them, so you would do x squared plus 4x plus 4. Okay, now we're gonna start off now with factoring polynomials. Still, not that hard. We're just gonna have to find the greatest common factor. The greatest common factor is basically, let's take 2x plus 4, right? And what is 2x plus 4 made out of, right? 2x is 2 and x. And 4, its factors would be 2 and 2. Now we're going to see that there are two 2's. So we'll try to get rid of this one. Get rid of this one, and now what are we left with? We're left with x plus 2. And so we're going to take this info and do 2 on the outside because we factored out 2. X plus 2. X plus 2. And that's factoring. Let's see if we could load up some practice problems. So now that we have practice problems, let's get the show on the road. So what do all of these share? We have 2ax minus 6ay. You might notice 2a can be divided from both sides. So we're going to do that. So 2a times x minus 3y. Because we took the 2a out of here, so we're just left with x. Then with 6a, we took out this a, and we divided this 6 by 2, which gave us 3. On to the next one. 4xh plus 2h squared plus h. This could seem pretty daunting at first, but I'm telling you it's easy. You just have to look at what all of these share. 4xh, 2h squared. Right now you'll say, why not divide it by 2? Because there's 4, there's 2, but there's also h at the end that we also have to divide by. So we're going to take out h. Now there's a common mistake here. Let me show you. We take out the h, so we do get 4x plus 2h because it's squared, plus, let me see if we can do it in a different color here. Oops. There you go. Let's go with that color, sure. This is important, plus 1. Some people, they divide the h by the h, and they just think, oh, it's gone now. It has to be 0. There's always a plus 1. All right, let's move on to the next one. T squared, and then there's t squared plus 9 plus t squared. Now, before you do anything, we look, right? We have t squared, 9, t squared. But the t squared and 9 are kind of separated from the other t squareds. And even though it looks like, oh, 9 is a perfect square root, you could just square it to 3. But because of that plus, you cannot do that. Let me show you. So we're going to take t squared out first. And when we do that, we will just be left with this. I'll go over it in a later episode on how to simplify more. But for now, we'll leave it like this. And remember, just because we divided by t squared doesn't mean it's 0. It's plus 1. There. The last problem, I'm sure you guys can do it now. It's basically like 2. Let's do it really quickly, 6xh plus 3h plus h. Again, we're in the same ballpark here. We know what to do already. We're just going to look. The last is h. Can only really get rid of h, so we're going to do it. H, so we have 6x plus 3 plus 1. All right. Now we'll go on to grouping. All right, now we'll start grouping. Grouping is basically like we have 4 terms here, and it's not really going to work out. You know what I mean? So you might look at this, you'll think, what if, take this as a barrier, this plus sign here. This only works with if you have 4. Now you do 2a, you look for the GCF. And so you'll take 2a from here, you'll take 6a from here. All right. So now you're just left with 2a x minus 3y. Right. Oh, let me fix that. And then now we look at the other side, 5x minus 15y. What is our greatest common factor? It's 5. Right. So let's get 5 out of here. There we go. And now you might be thinking to yourself, hey, these two look very, very similar. They're actually exactly the same right here. Okay. And you must be thinking there should be some other way to simplify this even more, right? And you'd be right. Very easy to simplify, very easy. All we're going to do is we're going to take these, we're going to put them together. And now we'll take these coefficients right here, and we'll put them together. So we're going to simplify it down even more into x minus 3y, so these. And then we're going to do times, we're multiplying, 2a plus 5. That's all it is. It's pretty simple. There's 2 steps, 3 steps. So we're going to go on to some practice problems. Just try to help you guys out. And we're going to leave the x plus 4. All right, here's some practice problems. I already separated for you guys. If you want to, you can pause and do it on your own, but it should be pretty easy, pretty simple. So we're going to separate it just like I did. And you might be seeing x cubed, but it's really not that hard. It's just there to scare you, that's all. So from x cubed plus 4x squared, what do we take out? X squared, the common greatest factor, the GCF, we're going to take out, okay? So let's do that now. So we got x squared plus x, right? Because x3 divided by x2 is x. Okay. Let's fix that up. So we got x squared, then x plus 4. Then we'll do these. You might be thinking, x minus 4, how do I factor this? You can factor out symbols right here. So let's factor it out. Minus x plus 4. You see what we have now? We were able to make both of these the same. So let's do what we did last time. Don't let that subtraction symbol throw you off. So we'll start off with x plus 4. And then let's choose a different color here. X plus 4. And then we'll do x squared. Do you know what you do with the subtraction symbol? You do minus 1. And technically, you can simplify this down more. We'll get to that in a later episode, but you can take this right here and simplify it into but we'll cover that later. I don't want to put too much on you guys. Now we'll do this one. This one's pretty easy too. Right? We're gonna separate it. There you go. And then we'll do common greatest factor. 9 goes into 18. So, and they both have x's, so I think we should take out 9 squared. Right? So we'll take out 9 squared right here. 9x squared. And then we'll put x plus 2. Because 18 divided by 9 is 2. And then we'll do subtracting x minus 2. We did this before. You can take out this. Just take it out. So now it should be x. Let's see how I can do this. That should be x. There you go. That looks bad. Whatever. Let's bring it down a notch. So now we have both x plus 2's. So we'll just do what we did last time. X plus 2. Then we'll take this right here. These are terrible colors. I need to work on my colors. Then we'll take the subtraction here. And then we'll just do 9x squared minus 1. And again, you can, if you want to, you can, this actually goes to 3x plus 1. 3x minus 1. You can simplify more, but I'll get to that later. All right, and that's basically it. That's just factoring polynomials in general, what they are. I'll show the uses for them later on. They look complicated when you're first starting out, but they're really not. They're not. Okay, I'll see you guys tomorrow.